everyone, today we will invent self-attention step by step. Self-attention means a word look at other words in same sentence to understand its meaning. So model does not read words alone. It reads with context. In this video, we need to understand like what is attention, why we need attention, and how attention weights work, and what query, key, and value mean. Self-attention is important because it is main idea behind the transformers. Transformers are used in many AI models. For example, chatbot, translation, summarization, and more. If you understand self-attention, then transformers become easier to understand. It is like understanding the engine first before learning the whole car. The problem is many older systems give one fixed meaning to a word, but in real language, meaning changes with context. Look at the word bank. Money bank means a place for money. River bank means land land near a river. Same word, different meaning. So we need a way to make word understand. Like it can change its meaning based on nearby words. The goal is contextual meaning. Let's build a simple solution. For one word, we will mix information from other words, but not equally. Some words more weighted more, some matters very less. So we need to create a weighted average. That means important words get bigger weight, less important words get smaller weight. Example, in money bank grows, the word money is very important for bank. So money should get higher weight. Now we need a method to calculate these weights. How to find weights? Using similarity. If two words are related in a sentence, their similarity score should be high. A similarity score method is dot product. Dot product gives a number, one number. Higher number means more similar, lower number means less similar. So we can use dot product to decide how much should this word pay attention to that word. Now we make our first attention model. Compute similarity score using dot product. So we get scores like 2.103 and 1.2, etc. Now we are going to use softmax. Softmax converts scores into weights. The weights become like percentages, and all weights added up to 1. Use the weights to take weighted sum of the word vectors. This gives a new vector for a word. This new vector includes context. So it looks like we solved the problem. But there is a big issue. The big flaw is the model does not learn what to focus on, because we're directly using word embeddings without learning new parameters. So it may work a little, but it is not flexible. It will struggle with deeper meaning. Example, piece of cake means very easy. But the model may still connect it with a real cake, because it did not learn that this phrase has a special meaning. So we need attention that can learn from data. Now comes the main idea. Each word will create 3 different vectors. 1. Query, what am I looking for? Key, what do I contain? Value, what information do I give? Think like this, a word uses its query to search and it checks other words, keys to see which matches. Basically, it checks other words' keys. Then it collects information from their values. Simple line, query asks, key answers, value gives. an easy analogy. Imagine a dating app. Ooh. Your key is your profile, what you are, and your query is what you want, what you are searching for. Your value is what you share in conversation, like useful details in your profile matching or like in conversations. So matching happens like this. Query compares with key, then you read the value if the match is strong. Small chalk. So query is your standards, key is your intro, value is your what you actually bring to that relationship. Now the important part. Q, K and V are not random. They are created using learnable matrices. We take original vector E, we multiply it with three different matrices. Q equals to E into WQ, K equals to E into WK, V equals to E into WV. These matrices WQ, WK, WV are learned during training. That means the model learns what kind of queries are useful, what keys should represent, and what value should carry forward. Now I describe real self-attention clearly. For one word, it's like take its queries, compare it with every word's keys using dot product. This gives a score. Apply softmax to attention weights. Use these weights to combine the value vectors. So the final output is a weighted sum of values. Query scores keys and weights combine values. Let's compare old version and new version. In our old version, we used row embeddings directly, no learning matrices there, so attention was fixed. In new version, we use Q, K, V, use trainable matrices like WQ, WK, WV, so the model learns how to focus better. Now, attention is not just a rule, it is skill learned from data. Quick check. Dot product between query and key tells what word? Second, WQ, WK, WV are what? Third, why do we split into Q, K, V? Let's see first. Dot product, it tells us how relevant one word is to another word. Weights are going to tell me they are training matrices. The model learns from them. And because one vector cannot do all the jobs, we need to split, making the system more flexible and learnable. Answer in the comments. You invented self-attention. We started with the problem words need context. We tried weighted average, then we saw flow that no learning is there. Then we introduced query, key, value, and we made them learnable using matrices. So now model can learn where to focus in a sentence. Great, but this is just one attention head. Upcoming video we will try to see multi-head attention. Multi-head means the model does attention multiple times in parallel. So different heads can focus on different patterns. One head may focus grammar, another head may focus on meaning, and another focus on long distance connections. Thank you for watching this video.